Good morning, everyone. In this unit, we will study the fundamental concepts used in RF frequency, integrated circuits, and wireless communication system. That is, in a modern technology such as mobile phones, Wi-Fi routers, Bluetooth devices, satellite communication system, and radar system that are all rely on RF circuits for transmitting and receiving the signal. In this unit, we are going to begin with S parameters and spectrum, which are important tools for analyzing the RF circuits. For example, if you design a Wi-Fi antenna, that is, engineers use the Smith chart to match the antenna impedance to the transmitted impedance in order to measure the maximum power transfer, in order to calculate the overall network efficiency, ensuring the maximum power transfer and minimal signal losses. Next, we are going to study about the passive IC components and impedance matching networks. Consider a mobile phone antenna connected to the RF amplifier. If the impedance are not matched properly, that is, if impedance are matched properly, we are saying about the there's a part of the signal gets reflected back, and it will automatically reduces the efficiency. That is, impedance matching network solves this problem. So, in this unit also covers the common source and common gate amplifier, which are widely used in RF front-end circuits. For example, common source amplifier can be used to amplify the weak signal. Generally, the amplifiers are mainly used to amplify the weak signal, right? So, common source amplifier can be used to amplify the weak signal received by the smartphone before further processing. And, and another important topic is a bandwidth estimation using an open circuit time constant. This will help the engineers to determine the frequency range for which the amplifier can operate it effectively. For instance, 5G communication system requires an amplifiers with a very high bandwidth in order to support high-speed data transmission. Finally, we are going to study about low noise amplifier, that is LNA. LNA amplifies a very weak signal while adding a minimal noises. So, for example, in a practical example, that is in a GPS receiver, that is in a smartphone, where the received satellite signals are extremely weak. So LNA will, that is a low noise amplifier, will use the signals so that accurate location information can be obtained. Another practical example of low noise amplifier is a mobile phone, that is in reading a voice call with the weak voice signal received from a distant cell tower. That will be amplified by the low noise amplifier by adding a very little noises. This helps to improve the voice clarity and reduces the background noise that allows us to hear the conversation clearly. Next, in this unit, it also provides the knowledge needed to design a high performance RF circuit design that are used in wireless communication. Wireless communication, IoT devices, satellite system, and modern electronic products. Next is S parameter and Smith chart. Generally, S parameter, what is meant by S parameter? That is, S parameter is nothing but scattering parameter. The scattering parameters are a set of parameters that are used to describe the electrical behavior of linear electrical networks. When it is especially at when it is at high frequencies. This will characterize how the signals will be transmitted and how it is reflected within a circuit. This will makes it essential for the analysis and design of RF, microwave, and communication system. Important is when it is a high frequency, measuring voltage and current directly becomes very difficult due to the transmission line, right? So, S parameters is the best convenient method in order to analyze the overall network performance in terms of incident, reflected, and transmitted signals. Applications is that applications is that is a RF and microwave circuit design, wireless communication system, antenna analysis, amplifier design, filter and matching network design, radar and satellite communication system. We can note that. Okay. Next, there will be the four S parameters for two-port network. That is S11, S12, S21, and S22. Note it down. That is, S11 is a input reflection coefficient, and S21 is a forward transmission rate. S12 is a reverse transmission rate, and S22 is a output reflection coefficient. These are the S parameters for two-port network. Thus, these S parameters are fundamental tools for understanding and designing the high frequency electronic circuits. Okay. Then the scattering parameter, that is, the scattering in S parameter, refers to how the waves are affected when they encounter a network. If a signal will be enters the network, the part of the signals will be reflected back towards the source, while the remaining portion will be transmitted to the network and reaches the receiver. The S parameters will quantify these reflection and transmission characteristics. So, S parameters are typically measured using vector network analyzer. That is, S parameters will be measured using VNA. VNA is nothing but vector network analyzer. It is a specialized instrument that measures both the magnitude and phase of a incidental, reflected, and transmitted signal over a range of frequencies. These measurement, that is, these parameters will be gives a detailed information about performance of total overall RF and microwave components such as amplifiers, filters, antennas, and transmission line. By analyzing this S parameter, that is a scattering parameter, engineers can evaluate the impedance matching, signal gain, insertion losses, return losses, and overall network efficiency. This will make them, and it is an essential tool for analyzing high frequency circuit design and testing. Is it clear? Then I have already told about there will be the four parameters for two-port network. What are they? S11, S12, S21, and S22. S11 is the input reflection coefficient. That is, have to consider it from right to left. Okay? Input reflection coefficient. That is, the portion of the input signal that is reflected back from port 1 due to the impedance mismatch. And S21 is a forward transmission coefficient. It represents the portion of the input signal that is successfully transmitted from port 1 to port 2. That is, we have to consider from right to left. So, this indicates a loss of gain in the forward direction. And S12 is the reverse transmission coefficient that represents the portion of a transmitted signal from port 2 to port 1. It indicates a reverse gain of isolation of the network. And S22 is the output reflection coefficient. It represents portion of the signal reflected back from port 2 itself, right? So, due to the impedance mismatch of the output. The importance of S parameters is that it is widely used to characterize and model the signal transmission between various RF and microwave components such as connectors, cables, transmission lines, antennas, filters, amplifiers, and waveguides. These S parameters helps engineers to analyze the signal reflection, that is signal reflection, transmission losses, impedance mismatch, that is impedance match. If the antenna, that is, if it is the impedance will be matched, perfectly matched, it means the entire signal will be transmitted to the loop. If it is not perfectly matched, that is a part of the signal will be transmitted to the source itself. That's a impedance mismatch. And it is this also used to analyze the gain and attenuation. And it is used to find out the overall network efficiency. By studying these S parameters, engineers ensure that the maximum power transfer, minimal signal losses, and proper impedance matching in high frequency communication and microwave system. Okay, is it clear? For example, in a mobile communication system, if antenna is perfectly matched to the transmitter, part of the signal will be reflected back. The parameter S11 shows the reflection and S21 indicates how much power is successfully delivered to the system. As these parameters will play a crucial role in designing efficient RF circuits and communication network. Okay. Okay. Let us see the applications of S parameter. Okay. Sample design, antenna design, regular characteristic situation, high speed, digital design, system design. These are the applications of S parameter. Okay. System design is a S parameter sets to optimize the performance of amplifier filters and antennas in order to work together. Okay. Software design is a in a RF amplifier, that is in a smartphone RF amplifier, the S parameters used to measure the gain and impedance match. These are the applications. In the next video, we are going to see about the Smith chart. Thank you.